we have been seeing in these videos the properties of determinants. So first we saw that determinant changes sign when two rows or two columns are exchanged. That was one property. The determinant of the identity is always 1 for any n dimension. The volume of an n-dimensional box is determinant of A, where this matrix A is the rows are the edges of the box, or the rows are the edges, so you pick the vectors and you put it in the rows of the matrix. In the last video we saw that the determinant is a linear function of each row. Okay. Another property is if two rows of a matrix, if two rows are equal, then the determinant is 0. Let us say we have a matrix AB and AB. Okay. What will the determinant of this matrix be? Well, that will be AB minus AB, okay, and that is 0. Okay, so if two rows are equal, then the determinant is 0. Please check for 3 by 3 and 4 by 4, etc. So we see another property: subtracting a multiple of one row from another row leaves the determinant unchanged. Let's say, for instance, we have 1, 2, 3, 4. So the determinant of this one will be 4 minus 3, that's minus 2, right? Let us say we subtract from this line this one multiplied by 1. Okay, so we do 3 minus 1 and 4 minus 2. Okay, we do this line multiplied by 1 and we subtract here. So that will be 1, 2, 2, 2, right? So 1 times 2 is 2, minus 4, that is minus 2. Okay, so checked, they are the same. Okay, so subtracting a multiple of one row from another row leaves the determinant unchanged. This property is more or less obvious. If the matrix has a row of zeros, then the determinant will be 0, right? Let's say we have 0, 0, 1, 2. We want to take the determinant. So that will be 0 times 2 minus 1 times 0. That will be 0. Okay, for any dimension, of course. A very important property: if A is a triangular matrix, then the determinant of A will be the main diagonal product of entries, the product of the diagonal entries. Okay, so if we have AB 0C, the determinant will be AC minus 0, right? So that will be AC. Okay, so it's a product of those two. Okay, and if it is lower triangular, that will be, the result will be the same. Okay, and the result will be the same for any dimension. If the matrix is A1, 1, 0, A2, 2, 0, etc., and ANN, okay, the determinant will be A11 times A22, okay, times ANN. Another property: if A is singular or non-invertible, then the determinant of A will be 0. If A is invertible or non-singular, then the determinant of A will be different from 0. Okay, so if we have a matrix A2 by 2, A, B, C, D, so the determinant of A, I'm calling A this matrix, will be AD minus BC. Okay, so it will be singular if and only if AD minus BC is equal to 0. Another important property is that the determinant of AB will be equal to the determinant of A times the determinant of B. The proof is really easy, I'm not going to do it. Okay. And another property is the determinant of A is the same as its transpose, right? So if we pick A, B, C, D, the determinant will be AD minus BC. If we transpose this, that will be AC, BD, right? And the determinant will be AD minus BC, and that's exactly the same. Okay, so the determinant of a matrix is the same as the determinant of its transpose.